Happy Tuesday and welcome to 5.1. Hopefully everybody did much better on your second version of the test. So let's go to this cumulative practice here. What you're wanting to do here are your angle pair relationships. And if I've got angle 1 and it's in the lower right and angle 2 is in the lower right, these are corresponding. Okay, so they're corresponding angles, and therefore if they're corresponding, they are congruent. They're congruent. So if we have this bottom one is 63, then that means angle 1 must be equal to 63 degrees. Why? Because they're corresponding angles. Same thing here with 2. I have lower left, so therefore angle 1 must be equal to 125 degrees. Why? They're corresponding angles. Kind of like that. Now, 5.1, find the measure of the angle. Didn't we just do that? We found the measure of angle 1. Find the measure of the angle. Angle 1, angle 2. Well, I don't see an angle, so I can't do this. I don't know. Maybe they were supposed to give us an angle and then we go measure it. Interesting. Okay. Now, hopefully you're going to like this lesson. I know transformations kind of probably threw you for a loop, but here, now we're going into something that you've been having in elementary school and middle school, classifying triangles by sides. Okay? So a scalene triangle, did all of this not download? Maybe that's what happened. So a scalene triangle is basically going to have 3 different side lengths. Okay, so they're all going to be different. Okay, and an equilateral is going to have, probably should have used my tool. It's going to have 3 pairs of congruent sides, as well as each angle is 60 degrees. Now, if it's an acute triangle is going to have, all acute angles. So all angles are acute. If it's obtuse, it will have 1 obtuse angle. So if it's right, we have 1 right angle. If it's obtuse, we have 1 obtuse angle. And if it's equiangular, it's going to have all angles congruent. Okay, so we've had all angles congruent. And more importantly, each one is 60 degrees. An equilateral triangle is also an equiangular triangle. They're the same thing. So if I tell you it's an equilateral triangle, you should know it's equiangular. Each one's 60 degrees. If I tell you it's an equiangular triangle, you should know that also means it's equilateral, so all 3 sides are the same length. Okay, so let's classify these triangles by sides and angles. So if we look at this first one, boom, I've got a right angle. So this is a right triangle. Now, I skipped over it up top. Isosceles triangle, at least 2 congruent sides. So we either have none or 2. Here, I've got my little congruent marks here. Tells me that I got 2 sides congruent. So this is a isosceles triangle. Okay. Okay, if we look at the solution, they say A is technically a scalene triangle, but since we have a 90-degree angle, we would call that a right triangle. Okay. Now, B, we would say technically that it's an isosceles, and since this measurement here is greater than 90, we would say it's an obtuse isosceles triangle. So they're wanting us to pick one from the top and one from the bottom. Okay. Now, let's classify this angle in the coordinate plane. Now, remember, in Desmos, you can do distance and then put in your two coordinates, x comma y, comma x1, comma y1, and it will give you this answer right here. Okay? All you got to do is put in the 2 points. So you could put in Desmos distance. Let's do D, -1, and then E, 2 comma 3, and you could find the length from D to E, and it'll spit out a 5. So the first thing we have to do is we have to find the length of all 3 sides. This is going to make it so much faster if you use Desmos. And since I can compare all 3 and none of them are the same, I would say that this is definitely a scalene triangle because that's the definition. Okay? Now, I know it's scalene. Is it a right triangle? Is it isosceles? It's not isosceles because we see that. Is it right? Is it acute or is it obtuse? So now we've got to look at slopes. And I haven't seen if they've got a slope formula in Desmos, but I'm going to make a note. Check on that. Okay? Maybe Madison will look for me. So we're going to calculate the slopes of each one of these lines. So we find that DF has a slope of 1/2. And then we're going to look at EF because we know this is the only possibility for it to be a right angle. So we calculate EF is -2, DF is 1/2, and when we multiply them together, we get -1. So yes, these slopes are the same. Now the other way you could have done it, remember, we'll finger count. We can do the slope is the rise 2 over 1, 2, 3, and then count. Count up and then count down. Okay. So we would say that DEF is a right scalene triangle. Okay. Now you're probably going, what other kind of right triangles are there? You can have an isosceles right triangle. And we'll talk about that a lot later because magic happens with that. Now, when you have a triangle, so here's my triangle. Okay. We have fixed lengths for the sides, but if I came back here and then decided to extend that line, so let's say I decided to extend each one of these. Oops, I didn't want to do that. Okay, what I've done now is these are my interior angles. We'll color them different because I don't know if they are the same. But then I've also turned around and created an exterior angle here. Okay, so the interior angles are the ones, as you can see here, on the inside. And then our exterior angles are the ones that are on the outside. Okay. Now, this is a huge, huge, huge theorem that you need to memorize. This is very important. Okay. Very, very important to know, to memorize. When you have a triangle, if I add up the measures of all the interior angles of a triangle, 1, 2, 3, angle 1 plus angle 2 plus angle 3 will always equal 180 degrees. Always. So if I have a triangle, I only need to measure 2 of the angles, and I can calculate what the third one is. Okay? So sum of the interior angles of any triangle is 180 degrees. Exterior angle theorem. So if we go up here and we extend the length of one of the sides of a triangle and we create this exterior angle here, 1, notice between both of these right here, okay, if we kind of got rid of, let me get the white, if I kind of got rid of all of this right here, it looks like I have a linear pair, does it not? And we know if it's a linear pair that they are equal to 180. So if I labeled this one as 2, we would be able to say that angle 1 plus angle 2 equals 180 degrees. So therefore, that's where this theorem comes into play. This theorem is telling us when we have an exterior angle of a triangle, it is going to be supplementary to its interior angle that it's adjacent to. Okay? We would be able to say, I'm going to number this, angle 1 and angle 2. So angle 1 plus angle 2 equals 180. And then what we're also going to be able to say, based on this theorem, is that angle 1 will be equal to the sum of the two angles it does not touch. Okay? Will be equal to the sum of the two angles it does not touch. So let's look at finding angle measurements. Wow, this just did not download correct, did it, at all? Interesting. So find the measure of ACD. Okay, well, I do not have the figure at all. And that's exactly what happened. Things did not copy over. Okay, so I'm just going to sit here and I'm going to draw it in for you. Okay, because you probably have it. So I'm going to draw it here. So I get here, and then I'm going here, and then here. Okay, and so we know that this is, what have we got? 7x plus 5. This one's 6x degrees, and this one's 37 degrees. Well, by the triangle exterior angle theorem, I know that this angle is going to be equal to the sum of these two. So I can write my equation down here and say that 7x plus 5 is equal to 5x plus 37 degrees. I'm going to simplify both sides, okay? I'm going to subtract 5 from both sides. You can see that here. Then I'm going to subtract 5x from both sides, and I'm going to get x is equal to 16. And so now I can go back in and take that x equals 16 and plug it in to both of these and find out what that angle measures. Okay, so we can actually say that ACD is equal to 117 degrees. Now, we've got a corollary to this theorem. Okay, so here's going to be our corollary. The acute angles of a right triangle are complementary. Let me draw one of these. So if this is a right triangle, and I know that's the right angle, okay, if I've got angle 1 and angle 2 here, I can say, we'll call this one angle 3. Oops, I'm on the wrong tool again. I could say that angle 1 plus angle 2 plus angle 3 equals 180 degrees. Well, I know that angle 3 is 90 degrees. So angle 1 plus angle 2 plus 90 degrees equals 180. Therefore, angle 1 plus angle 2 must be equal to 90. And that's what our theorem states, because I can prove that every time. Why do I need to go and draw this out every time? If I have a theorem, I know I can prove it 100% of the time, I'm going to write a theorem, okay? So when you have a right triangle, when I have a right triangle, oops, that's a terrible right triangle, I know that the two non-right angles will add up to be 90 degrees. Okay, so now finding angle measures. Find the measures of each angle in RST. So here we've got our triangle. I know y'all have it on yours. I do not, however. How much fun. We know that R, so this is R, it's a right angle, okay? We know that T has a measure of 5x plus 3, and we know that S is 3x minus 9. Now, I can go through the trouble of saying angle T plus angle S plus angle R equals 180, or I can use my right angle theorem and just say that these two are equal to 90. So I can come back now, and you see it right down here, 5x plus 3 plus 3x minus 9 equals 90. So it's still the same math, I just saved myself a couple of steps. And we're going to find out that x is equal to 12. And now that I know that x is equal to 12, can I plug it back in to both of my expressions and know exactly what those angle measures are? And the answer is yes. You can see right here. They plugged it back in. Okay. Now let's look at exercise 1. We are going to classify these angles. Okay, so we are going to classify them. I know that is here. By measuring its sides. Okay, first one, I know this is going to be a scalene right triangle. Now over here I've got 2. Okay, I've got 2 sides congruent, and it doesn't look like I have any right angles. So I would say that this is an isosceles acute, because all angles are acute triangle. Okay, isosceles acute. Now, here we've got next exercises 3 and 4. Triangle QRS, we want to classify it by its sides and then determine whether it is a right angle. Okay? Now, several different ways you can do this. Probably what I would do is I'm going to graph it in Desmos, and then I'm going to compare those slopes. I'm going to count rise over run and see if I've got any of my slopes that are negative reciprocals of each other. Okay? Now, in 5, again, I've got to draw it because I don't have it, and I don't understand why I don't. Okay? So, find the measure of the exterior angle. So, to find the measure of this exterior angle, we're going to be able to say that this angle is equal to the sum of these two. So, I'm going to be able to write the equation that 4x minus 18, which is my exterior angle, will be equal to 2x plus 6 plus 36. And so I'm going to end up getting 4x minus 18 is equal to 2x plus 42. I'm going to get 2x is equal to, what is that going to be, 60? So x is 30. And then I can plug them back in. Now on the second one here, what have I got? I've got a right triangle. Okay. And because I already know we've got 2x and then we have what, 3x plus 5? Since this is a right angle, I don't need to add that back in. I can simply say that 2x plus 3x plus 5 is equal to 90. So 5x is equal to 85 and x is going to be equal to 17. Okay? So big concepts here are your triangle angle sum theorem. The sum of the interior angles of all triangles is equal to 180. Okay? So we've got that one. Your exterior angle theorem, which says an exterior angle is equal to the sum of the measures of the two non-adjacent interior angles. Remember, this angle 2 would be adjacent. And then, if you have a right triangle, the two non-right angles in that triangle will be equal to 90. Okay, right now, that's finished with the lesson, and go on to Big Ideas Math and get started on lesson 5.1. See you tomorrow.